Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's derive the rule on differentiating a constant. So we are going to prove this theorem for the rule on differentiating a constant. It states that if c is a constant and if f of x is equal to c for all x, then the first derivative of our f of x is just equal to 0. Let us try to show the proof of this using the definition. Take note that for f of x, okay, for any f of x, its first derivative, okay, is equal to this definition, the limit of f of x plus increment of x minus f of x all over increment of x as the increment of x gets closer to 0. Okay, so this is the definition of differentiation, or other references would also like to use this notation as instead of increment of x they use h, because for easier manipulation of your proof. Okay, so both of them are just the same, but basically we are going to use this as this is the definition which includes increment of x, which considers as even the small change in the value of x. So we are going to show that for f of x be equal to c, we would end up with f prime of x, or the first derivative, being equal to 0. So let's try using this definition. So the proof here, of course, so we'll have f prime of x is equal to the limit of f of x plus the increment of x minus f of x over the increment of x as the increment of x is or getting closer to 0. Of course, we cannot substitute that here because this will become 0. So what we could do is assume the values of f of x plus increment of x and f of x here. Since f of x is already given as c, so this is already its value. But of course, part of the definition is that f of x is equal to c for all values of x here. So even if x is changed into x plus delta x, this is still equal to c, because for all, if you have here f of 2, that's a c. If f of k squared plus xy, this is still equal to c, because for all x, for all functions of for all x, okay, the function is equal to c. So let me remove the other scribbles that I have made. So since both of them are equal to c, substituting them in our given here, we have the limit, we have f, this expression is equal to c, and this one minus c is equal to the increment of x as the increment of x is greater, or delta x, other way delta x approaches to 0. Okay, do not solve the limit yet because we will still get 0 denominator. What we need to do is this is equal to the limit of 0, that's c minus c, over the increment of x, which is just equal to the limit of 0 as the increment of x is equal to 0. By the limit theorem for constant, this is equal to constant itself. So we have proven here, therefore, f prime of x, this portion, is equal to 0. Sorry, that's 0. Okay, this is the proof for this given theorem, which tells us that in future computation, if we have f of x, which is the constant, its first derivative is just automatically, no matter what the value of constant is, whether it's positive, negative, rational, irrational, it will always be equal to 0. Thank you very much for watching. So what are you waiting for? Subscribe now.